Hello, today we will discuss average sample number and average amount of total inspections. This is very important topic for you. The average sample number is the expected value of the sample size required for a decision about the acceptance or rejection of the lot in an acceptance rejection sampling plan. Okay, the average sample number is nothing but the expected value of the sample size required for a decision about the acceptance or rejection of the lot in an acceptance rejection sampling plan. Obviously, it is a function of the incoming lot quality P. Okay, it is nothing but a function of the incoming lot quality P. And on the other hand, the expected number of items inspected per lot. Okay, the expected number of items inspected per lot to arrive at a decision in an acceptance rejection sampling plan calling for 100% inspection of the rejected lot is called average amount of total inspection, that is ATI. The expected number of items inspected per lot. Okay, you are inspecting some items from each lot. So the inspected number of items inspected per lot to arrive at a decision in an acceptance rejection sampling plan and calling for 100% inspection of the rejected lot is called average number of total inspection. Obviously, ATI, that is average amount of total inspection, is also a function of the lot quality P. Okay, ATI is also a function of the lot quality P. Thus, we observe that ATI Okay, ATI is equal to ASN, average sample number, and plus average size of inspection of the remainder in the rejected lot. Once again, ATI is equal to ASN plus average sample, not average size of the inspection of the remainder in the rejected lot. And let it be equation number 1. Thus, if the lot is accepted on the basis of the sampling inspection plan, okay, if the lot is accepted on the basis of the sampling inspection plan, then ATI is equal to ASN. This is very important. Means in that case, ASN is equivalent to ATI. Otherwise, ATI is greater than ASN. In other words, ASN gives the average number of units inspected per accepted lot. Okay, ASN gives the average number of units inspected per accepted lot. For example, if a single sampling acceptance rejection plan is used, if a single sampling acceptance rejection plan is used, then the number of items inspected from each lot will be the corresponding sample size. That means ASN is equal to N. Okay, now next. However, for an acceptance rejection sampling plan calling for 100% inspection of the rejected lots, additional capital N minus small n, where capital N is the lot size, capital N minus small n items will have to be inspected for each rejected lot, where capital N is the lot size. Thus, in this case, the number of items inspected per lot varies from lot to lot. Okay, thus in this case, the number of items inspected per lot varies from lot to lot, means it is not fixed and is equal to N. If the lot is accepted and equal to capital N, okay, it is equal to capital N if the lot is rejected on the basis of the sampling inspection plan. So you have two cases. If lot is equal to n, small n, and other condition is lot is equal to capital N. Hence, the average amount of total inspection, okay, average amount of total inspection is a function of the lot quality P, and which is given by ATI is equal to N into L P in bracket P plus capital N in bracket 1 minus L P, and let it be equation number 2. So this is your formula. ATI is equal to N into L in P plus N, capital N, in bracket 1 minus LP, and let it be equation number 3, where LP is equal to P0P and is the probability of acceptance of the lot of quality P. Okay, LP is the probability of acceptance of the lot of quality P on the basis of the sampling inspection plan. Now we rewrite equation number 3 as ATI is equal to N, small n, and in bracket ATI is equal to N into LP plus in bracket capital N minus small n plus small n multiplied by another bracket 1 minus LP, bracket close. Now we expand this. This is equal to N into LP plus in bracket capital N minus small n and into in bracket 1 minus LP and plus n multiplied by in bracket 1 minus LP. This is, we have simply expand. Now this will be equal to small n plus in bracket capital N minus small n and in another bracket multiplied by 1 minus LP. Thus we see that ATI is equal to N, small n, plus capital N minus n multiplied by in bracket 1 minus LP, and let it be equation number 4. So this is the formula for ATI. Now some points are which should be keep in your mind. Number 1 point, in single sampling inspection plan, okay, in single sampling inspection plan, the common practice is to inspect the entire samples even though the decision to accept or reject the lot is reached before the entire sample is inspected. Okay, hence ASN, that is average sample number, in a single sampling plan is equal to small n. Similarly, in a double sampling inspection plan, the entire first sample is always inspected, means first sample, whole the first sample is inspected first, and then after we do sampling. That is why it is double sampling inspection plan. Now point number 2, the ASN and ATI, if plotted against the lot quality P, then it gives you the ASN curve and ATI curve respectively. Means if you plot ASN against the lot quality P, then you will get ASN curve, and if you plot ATI against lot quality P, then you will obtain ATI curve. And these curves are useful in comparing the efficiency and cost of the sampling inspection plans. So this is very important. These are useful in comparing the efficiency and cost of the sampling inspection plan. In some situation like destructive testing or variables inspections, the rejection of the rejected lot is not feasible or practicable, and the ATI curves are not used. In such a situation, ASN curve is used. Okay, so this is your ATI, ASN. Now we will discuss single sampling plan. What is the single sampling plan? You should know about this. If the decision about accepting or rejecting a lot is taken, okay, if the decision about accepting or rejecting a lot is taken on the basis of one sample only, comma, the acceptance plan is described as single sampling plan. Once more, if the decision about accepting or rejecting a lot is taken on the basis of one sample only, then the acceptance plan is described as single sampling plan. Let capital N be the lot size, okay, small n be the sample size, C is the acceptance number, that means maximum allowable number of defective in the sample. Once again, C is the acceptance number, that means maximum allowable number of defective in the sample. The single sampling plan may be described as follows. Number 1, we select a random sample of size n from a lot of size capital N. In second point, we inspect all the articles included in the sample. and let D be the number of defectives in the sample. Okay, we inspect all the articles included in the sample, and D is the number of defectives in the samples. Now, third point, if D is less or equal to C, then we accept the lot and replacing defective pieces which is found in the sample by non-defective ones. Means if D is less than C, then we accept the lot and we replace defective pieces by non-defective ones. And fourth point is that if D is greater than C, then we accept the entire lot and replace all the defective pieces by standard 1. Means if D is greater than C, then we inspect we inspect the entire lot and we replace all the defective pieces by standard 1. So this is very simple topics and very important to know for you. So that's all of today class. Thank you. If you find any problem, then discuss with me. Okay, thanks.